Alright, so the next section in our notes is going to be called evaluating function notation. So first things first, evaluating, make sure you're writing all of this in your notes, is replacing a variable everywhere you see that variable when you're given that variable's number. This is just a fancy-dancy way of plug in a number for your letter. Okay? And if you have that letter several times, then you will plug in that number several times. So let's look at this first doodad bit. Yes, you will have to copy all of this. So for example, 1 here, let's look at this. Evaluating explicit functions. We have f of n is equal to 2 minus 3. So what I'm saying is, in this explicit one we evaluate, if this n gets replaced with a number, then we replace this n with a number as well. So in this case, we have f of 0. So what I'm going to do is I'm going to replace everywhere I see an n with the number 0. So I have repeating this, so I'm just replacing this n. So I have 2 times 0 minus 3. All I did was replace this n with the number 0. Because again, here, 2n means 2 times n. I keep that multiplication. Now all I do is simplify. So I have f of 0 still. 2 times 0 is 0. So now we have 0 minus 3. We didn't do anything with that minus 3. Then we have f of 0 equals, well, 0 minus 3 is negative 3. And that is it. That's my answer. Let's do it again. So this time, my f of negative 2, this means that my n equals negative 2. So I'm going to replace in this equation, where you're still working with this equation, 2 times negative 2. I'm replacing that n with that negative 2 minus 3. Okay, still using this equation, but down here. So now I'm going to do some math stuff. So f of negative 2 equals 2 times negative 2 is negative 4. So now we have negative 4 minus 3. We didn't mess with that minus 3. Which gives us f of negative 2 equals negative 4 minus 3 is negative 7. Final answer. Looking at our next one, we have f of n is equal to 3 times 2 to the n. This is a geometric. So again, here are my n's. So if I get a number for inside here, I'm going to replace this n with that number. So we have the number 1. So what I'm going to do is I'm going to replace this n here with a 1. So now I'll have 3 times 2 to the 1. I'll write that in purple. To the 1. 3 times 2 to the 1. So exponents first. 2 to the first power is just 2. So we have 3 times 2. F of 1 equals 3 times 2. And then f of 1 equals 3 times 2 is 6. And that's my final answer. F of 7. So this time we're going to replace our n's with 7, right? This is saying n equals 7. So we'll have 3 times 2 to the 7. Well, 2 to the 7 is 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. So 3 times 128, sorry, f of 7, 3 times 128 gives us, let's see, 128 times 3, that's a 4, that's a 2, 6, 7, 8, 384. Okay? So that's evaluating with an explicit. You've probably done this before, just not with the function notation. All right, the next thing I want you to do is I want you to copy this table. We're going to evaluate functions with a table. So copy it down because I'm going to get going. Pause the video. All right, so first things first. Let's look at examples 3, 4, 5. So in example 3, we have f of negative 4 equals something. Well, this negative 4 means n equals negative 4. So that means I need to look in my n row and find negative 4. And here it is, and its partner is my answer, 16. Looking at the next one, we have f of 0 equals something. So I look in my n column because n is equal to 0. I find 0, his partner is negative 4. That's what we're figuring out. The next one we have is negative 2. So this is saying n equals negative 2. So I find negative 2 in my n row, and his partner is 6. Okay. Now let's look at example 6. Well, now we're told f of n is equal to negative 9. Okay, so let me pick a different color here. So now we are set negative 9. We need to figure out our n. So f of n equals negative 9. So f of n, we're looking in the f of n column now for negative 9. It's back here. Its n partner is 1. So n is equal to 1. Now, not only that, but let's take this 1 that n equals and we're going to replace it here. So now we're going to have f of 1 minus 1. Well, 1 minus 1, well, this gives me f of 0. And f of 0, looking at my table, this is saying, hey, n equals 0 is negative 4, right? That's this guy right here. Let's look at example 7. Now we are told f of n is equal to 6. Well, we need to figure out our n. We don't know that. So what we're going to do is look in our f of n, find 6. Here it is. And its n value is a negative 2. Now we know n is negative 2, so let's replace the n here with negative 2. So we have f of negative 2 minus 1. Negative 2 minus 1 gives us f of negative 3. F of negative 3 is this guy right here, which gives us an 11. Again, if you need to rewatch this, absolutely, please do. All right, next up we got f of n equals 1. So again, we need to figure out our n, so we're going to look at our f of n column for 1, and it's right here. Its partner, its n, is negative 1. We now know n is negative 1, so let's replace it in f of n minus 1. So now we have f of minus 1 minus 1. F of n, or f of minus 1 gives us f of minus 2. F of minus 2, looking at my table, is this guy right here, 6. Okay. Your homework is 1.3. You just do the ready and set. Go is extra credit, which means you don't have to do it. So all you have to do is the ready and the set. Okay? All right, everyone. Make sure you're writing your notes because they'll be worth points at the end of the unit. Have a good one.